Hello, welcome to the neural network session. We are going to focus on the perceptron for us to get a clear understanding of how deep learning works in machine learning and what makes up a neural network. So the objective of this session is to introduce the neural network in machine learning by looking at the perceptron as an overview. As we move through the feed forward in the perceptron from the left to the right, and we are also going to introduce activation in a perceptron. Let's just look at the neural network. The basic components that make up a neural network are the input layer, the connections, the hidden layer, and the output layer. Coming from the left, we've got the input, and the far right, we've got the output. Whatever is in between the input and the output represents our hidden layer. And whenever we have got more than one hidden layer, we can call that a deep learning. So think of it, deep learning is going to be represented with more than one hidden layer in our neural network. And the more we have got the hidden layers, we call that deep, and that's where we think that we then assume that learning patterns happens in the deep learning. We understand that in a neural network, we learn features coming from the low level to the middle and to the high. Therefore, the more we have got more hidden layers, the more we build capacity of the model to extract and to learn patterns in data. However, it is also important that you understand that as you increase the hidden layers, you are also exposing your model to a risk of overfitting. And overfitting happens when the model does not generalize, or it gets to understand more of the training data over when you present to it unseen data. And you would want your model to generalize in order to avoid overfitting. So the more you add more layers, the more you are giving more capacity to the model, and therefore the model might end up learning noise data. Let's now extract just a neuron out of the hidden layer. So we are going to maintain our input. We're going to only extract one neuron from the hidden layer, and then whatever comes out of the neuron is going to be the output, which becomes the input to another layer that comes after it. And the basic component that make up the perceptron is the input, the weights, the neuron, and the output. As we proceed, we're going to introduce bias and activation function. For now, let's proceed and understand what happens by adding some variables in the input and the weights. So now we have introduced x1, x2, and x3, and our connections, which are our weights, we have introduced w1, w2, and w3. And we understand that in the neuron, what happens that the neuron holds a weighted sum. So it holds x1, w1, add x2, w2, add x3, w3. And whatever is summed up within is going to be pushed out as the output in simpler. However, you will see that we will need to add a bias which allows the perceptron to shift its decision boundaries from its origin. You can also think of it that in a way as trying to put a boundary, changing the boundaries of the solution, trying to avoid ending up having the same results being produced from each and every neuron. So we are going to add something that is going to look like is a threshold in some way, helping us to control the output. And We are also going to introduce the activation function, and the activation functions allows us to add non-linearity in the model, thereby helping the neural network or the perceptron to learn complex patterns and thereby becoming accurate approximators. So coming from the left, we have got the x1, w1, and all these are going to be summed up so that we end up with the weighted summation. Once we have that value, we are going to add the bias, and then we are going to push it through the function, the activation function, and whatever comes out of the activation functions is what we call the activation, and that is the value that goes as output and becoming input to the next layer. Let's consider an example whereby we would want to play cricket, and we are going to push in features of the weather, and in this case we are going to be dealing with a sunny day with normal light, and wind is also normal. And when we put in the features, definitely they are going to be represented using numeric data, depending on how and which feature has got greater value. In this case, sunny is being considered as having greater value, and light at 3 and wind at 2. And what we'd want to determine is whether we are going to play cricket or not. And in this case, when we get a 0 as output, we are not going to play cricket. And when we get 1 or above, we are going to choose to play cricket. So when you input your information into your model, what then happens is that the model or the neural network is going to, by default, select different neuron weights for each connection and for each feature. And in this case, let's take an example that our neuron and our perceptron manages to pick 2, 2, 1 as being the weights or the connections for between our input and our neuron. What then happens in the neuron is that the neuron then does a summation, which is a weighted sum. So we're going to multiply 5 by 2, 3 by 2, and 2 by 1. And whatever value that we're going to get, we're going to introduce bias. And in this case, our bias is 10, meaning to say that the bias there controls whatever value that we get, and it's going to shift its boundaries. In this case, it's going to shift the boundary backwards. And once we get that value, we are going to introduce our activation function, and then we're going to determine whether the value is a 0 or a 1 and above. So we do the weighted sum, and we are going to add 10, 6, 2, and we're going to less the bias or add the bias, which is a minus 10 to that function. This gives us an 18, and then 18 add minus 10. That's going to give us a result of 8. And then we are going to see how we apply the 8 to the activation function. So we are going to add the activation function, which is ReLU. And the ReLU basic formula says that ReLU, what it does, it says whatever value that is going to be the weighted value coming and passed to the function is going to do a max 0x, meaning to say that what it does is that for x is less than or equal to 0, it's going to give it a value of 0. So whenever we have got the value coming through to the activation function, it's a 0 or below 0, it's going to be defaulted to 0. And whenever we are going to have x being greater than 0, it's going to return that value as it is. So let's go back to our example where we have got x being 8. So we introduce 8, and therefore our max value is going to be 0.8, and therefore it's going to select the maximum between 0 and 8, and therefore we're going to get an 8. And whenever it is an 8 and we're going to introduce the activation function, remember what we said, activation therefore chooses the value that is maximum between 0 and x. So in this case it's an 8, and if you're going to compare with our output, x is greater than 0, therefore we are going to play cricket. This is how the Perceptron operates and all the functionality that are in there in a simpler terms. So you are coming from the left to the right, and all features are going to be converted, given them numeric values, and the neural network is going to assign some weights to each and every connection and the default bias, which are going to be computed together, and whatever we get, we're going to apply an activation function. In our case, we used the ReLU activation function to determine the output. And remember that whatever is produced from the activation function is called an activation. Let's go on to look at another example. Again, trying to determine whether we play cricket or not. And in this example, the weather is no longer on a sun, it's a rain day, and the light remains normal. However, the wind is now windy and not normal. So depending on how important those are, we can see that the input values there have changed, and also the weights still remain 2, 2, and 3, and the weights have changed again to 2. Now let's proceed to see how the the Perceptron is going to calculate this example. So we're going to do a weighted sum in the neuron, and we're going to multiply 1 by 2, 3 by 2, 1 by 1. And we're going to introduce the bias, which is a -10, before we pass through the activation function and determine the activation. So we're going to end up with a 2 plus 6 plus 1 less 10. This is going to give us a 9, and then we introduce -10 to the bias. This then gives us a -1, and then we want to pass the -1 into our in our activation. So when we pass through the activation, and the activation is ReLU. And again, we understand what ReLU does. It's going to choose a max between 0 and x, and our x here is -1. So when we choose the max between 0 and -1, we discover that the 0 is greater than -1. Therefore, the value of the activation is going to be 8. And once we have gotten 8, then we can go and check whether we are going to play cricket or not. And in this case, we are no longer going to play cricket because of the weather conditions and the features that are there. This is how the feed-forward works as we introduce bias and activation in our neural network, making use of the Perceptron. We come to the end of the neural network as we try to understand it from the Perceptron view. Remember to like if you are new to this channel. Also remember to subscribe to the channel so that you don't miss future videos that we're going to upload. Your comments are also valuable to us. Please drop in the comments, and whenever you need another video and another topic that you need us to concentrate on, kindly put it in the comment, and definitely we will respond. Bye.